Hi everybody and welcome. Today we're going to be taking a look at ratios and solving proportional relationships. What this is ultimately setting us up to do is looking at similar figures and basically seeing if we have some dimensions of a figure that is related to another one, we're going to be able to use those related dimensions to ultimately find the missing sides of the figure that we do know. So using that as our guide and our baseline, today we're going to get the basic skills for solving, and then after we have those basic skills, we'll be able to apply it to our context. So the first thing that we need to know is a ratio. And a ratio is the number of times one quantity contains another. So for example, when I like to avoid going to Crumbl Cookie and don't want to spend $1 million on cookies for myself and my wife, I have my own recipe for it. And that recipe, what it does is it makes 24 cookies, which is a ton because it's just me and my wife. And that's a lot of cookies for two people. So sometimes what I try to do is I try to cut it down, and instead of making 2 dozen cookies, to just make 12 cookies instead. So what that means is for all of my ingredients, I have to follow this same proportional relationship where if I have 2 cups of flour, I now have to proportionally reduce it to X cups of flour. And if I do it in the same way that I went from 12 to 24, well, I divided 24 by 2 to get 12. So I would divide 2 by 2 also, and that would tell me that I should use 1 cup of flour. So basically reducing everything by half. Now that cookie recipe is a pretty straightforward example because we're just reducing everything by half, but sometimes it won't be that straightforward. Sometimes we'll be using this and setting it up in a way that makes it a little bit more challenging to find those quantities that we're looking for. So word problems are a really good context for these proportional relationships. So if we're looking at the total number of students who participate in a sports program at a high school, and we know that the total number of students in that school is 1850, we want to find this ratio. So it's telling us athlete to student ratio. So we have 703 athletes, and we have 1,850 students. So the athlete to student ratio is like so. Now the key concept here though is we have to make sure that we are getting this down into understandable terms. So what we do is we take our smaller term, 703, and we're going to divide both sides by 703 to get our full ratio here. So if we take 1850 divided by that 703, we're going to see 1 athlete for every approximately, it's like 2.6 and a few decimals, students. So that's another more useful way to use our ratios is to get it to a quantity of 1, and the way that we do that is we choose our smaller number and divide both sides by that smaller number. So ratios work the same way in triangles. And what we can see here is when we have triangles, we'll call side A, B, and C. And if these triangles are in any way, shape, or form similar, it allows us to set up these ratios as well. So if we have a second triangle that is similar, we can have A prime, B prime, C prime. And we can basically know that the ratio of A to B to C is the same. So question 2 shows us an example of how we apply this to triangles. Is we have our side relation of 5 to 12 to 13, and it tells us that all of these things, if we add them up together, gets us 90. So what it's saying is we have 5A plus 12B plus 13C, and if we take all of these things, we know that it has to add up to 90. So we have a few options for this, but the main idea here is 5, 12, 13, and a perimeter of 90, we're going to use the same variable for all of these, because if we double 5, that means everything gets doubled because the ratio is the same. If we triple it, if we multiply it by 4, whatever it might be, because it's in the same ratio, it's a constant ratio of 5 to 12 to 13, we're not allowed to change that. So if we make it bigger or smaller, or any of the things in between, this is what helps us solve. So if we're trying to find the measure of the shortest side of this triangle, we'd have to do is combine our like terms. So all of these are actually x's here. So this adds up to 30x equals 90. 5 plus 12 is 17, plus 13 is 30. Divide both sides by 30, and we'll end up with x equals 3. So what that tells us is the shortest side of this triangle, we can take that x equals 3 and plug it back in for x, and it tells us that we'll have 15 for side A, 36 for B, and then 39 for C. So it's still in that same ratio of 5 to 12 to 13, but just a little bit bigger, and in fact 3 times bigger, and that's what's going to get us a perimeter of 90. So ratios can be a little bit tricky to work with. Not my favorite thing to work with when given the opportunity and the option. It's usually a lot easier to work with proportions. So if we flip over to the next side here, proportions are what we deal with next. And the easiest way to remember these, I remember if you've seen that movie Black Panther, Wakanda Forever makes an X. So if you make your X, your cross multiplying, that's going to be how we solve a proportion. So keep the equal sign in the middle and multiply across. So one side across, we have 5 and x. And then the other side across, we have 3 and 75. So 3 times 75 gets us 225. The last thing that we need to do is just get x by itself, so we'll divide both sides by 5. And that'll get us an answer of x equals 45. So that is our little bit more straightforward example there, but these do keep going and they do get a little bit more extended in terms of the challenge level. So for the second one, we'll work through this one as well. Still cross multiplying, so still making our Wakanda Forever x. So on one side, we have 4 and 13. So first off, 4 times 13 will get us negative 52. And then on the other side, we'll do 2 times 3x minus 5. And if you have multiple terms, we just have to make sure we distribute to both of those terms. So it's 2 times 3 and 2 times that negative 5. And that's how we're going to be able to solve this one. So 2 times 3 gets us 6x, and then 2 times negative 5 gets us 10. We can add 10 to both sides. Divide both sides by 6, and we'll get x equals negative 7. So that's the key there. I'd say that the main trick is knowing that we do have to do that distribution on that step. Last question, I'll have you solve this one. Just decimals, so don't be afraid to use a calculator. What do we get for an answer of y after we finish solving this? So again, cross multiplying, we should get 4y, and then using that calculator, 2.3 times 3.4 gets us 7.82. Divide both sides by 4, and we'll get an answer of y equals 1.955. So there's our answer for that one. The last one is when we take these proportions and apply them to real world things. So some key things that we want to make sure we do is still use that same setup. So first, let's take a look at the question. A boxcar on a train has a length of 40 feet and a width of 9. A scale model of the same boxcar with the same dimensions, this time has a length of 16, and we're trying to find the width. So the key that we have to do is on one side, we're going to have the actual boxcar, and on the other side, we're going to have the model. On the top, we're going to put our length, and on the bottom, we're going to put our width. So as a setup, only dimensions from the actual boxcar can go on the left, and on the right, only dimensions from the model. So you have to make sure you keep those things separate. Same thing with putting the lengths on the top and the widths on the bottom. So length of the real boxcar is 40, its width is 9. So length of 40, width is 9. And for the model, the length is 16, but we don't know the width, so that's where x comes in. So from here, this is just where we set up our cross multiplication. So 40 times x, and then 16 times 9. And then we can divide both sides here by 40. We'll get an answer of x equals 3.6, and our model is in inches. So lots of decimals today and some tricky things to work through, but as long as you are being careful with your units and you set up your proportions well, that cross multiplication, Wakanda forever, that's going to be a great way to make sure that you're able to go through and finish solving these. So as always, thanks for watching. Let me know if you have any questions, and you're ready to start.